Good morning, everyone. In today's lecture, we are going to learn about the properties of ROC. Before we start with the properties of ROC, we need to know about poles and zeros, which are very useful for us in this lecture. Poles and zeros. So if we have a rational function denoted by xs given as x of s is basically a rational function of s, or you can say x of s is basically a naught s raised to the power m plus a1 s raised to the power m minus 1 plus so on up to a m, and in the denominator we have s raised to the power n plus b1 and so on up to bn, where this is your numerator and this is your excuse me, denominator polynomial. Okay, or better to write it in this way, that this is equals to numerator polynomial upon denominator polynomial. So if it is a rational function of s, then we can say that it's equals to a naught upon b naught, and we have roots of the numerator polynomial as s minus z1, s minus z2, and so on up to divided by roots of denominator polynomial s minus p1, s minus p2, and so on s minus p2, where you can say the numerator roots are z1, z2, and so on up to zm, and denominator roots are p1, p2, and so on up to pn. So the roots of numerator are zeros. Why they are zeros? Because if you will put s equals to z1 in this equation, then the xs will become equals to 0. That's why they are called as zeros. And roots of denominator are called as, or known as, poles, because when you put s equals to p1 in this equation, in the denominator, or you can say the equation of x of s, then the xs will be equals to infinite. So for this, xs will be equals to 0 for zeros, and for them x of s will be equals to infinite. That's why they are called as poles and zeros. Now if you have, if it's a proper rational function, if x of s is a proper rational function, then m is always less than n. If it's not, if x of s is improper or not proper rational function, then m is greater than or equals to n. Okay, so now we are ready to know about the properties of ROC, because the properties of ROC depends upon x's. So we define them according to the polynomial x is given to us. So you now, let's say, properties of the region of convergence, or you can say ROC. So the first property is the ROC of x of s consists of strips which are parallel to the j omega axis in the S plane. What that means is the ROC of axis consists of strips which are parallel to the j omega axis in the S plane. So if we sketch it, so if you know, S is equals to sigma plus j omega, and this is your sigma and this is your j omega. So the ROC will be containing the strips which are parallel to j omega axis. It means it will be, the ROCs are like this, maybe like this. So any one of them can be ROC. So it will be in the form of strips which are parallel to maybe this or maybe this, but they are always the strips which are parallel to j omega axis. Second property is for rational Laplace transform the ROC does not contain any poles. If you want to see it in this way, that for any axis given to us, let's say axis is x of s is given to us as 4s plus 5, and it is s square plus 4s plus 3. So we rationalize it, it will be divided by s plus 3 and s plus 1. So the jets are, you can say zeros are minus 5 by 4, 5 divided by 4, and the poles are minus 3 and minus 2. So you have two poles, so minus 1, sorry. So if we'll put s equals to minus 3 in this equation, the xs will be equals to infinite. For them, x of s will be equals to infinite. So if the ROC will contain any pole, then you will not be able to find the Laplace transform of it. So that's why for rational Laplace transform, the ROC does not contain any poles. Third property is, if xt is absolutely integrable and is of finite duration, then ROC is entire S-plane. For example, if we have xt equals to, let's say 1, between 1 less t less 2 and 0 else, then you can say that it is defined between only 2 points, but it's of finite duration, and then x of s will be from 1 to 2, 1 into dt, and so it will be 2s, sorry, so the ROC is, you can see the entire S-plane, because there is no point where we have to remove the infinite thing. If you remember, in terms of, if we have term like e raised to the power minus st, and we have t equals to infinite or t equals to minus infinite, so then we have to find the points or find the condition on s or s plus 1 something, whatever you have here, which will give us a ROC for which this signal will be defined. So in this case, it is absolutely integrable, and you can easily find out that ROC is your entire S-plane. So if your xt is absolutely integrable, then your ROC is always the entire S-plane. Then property 4, if x of t is right sided, if xt is right sided, and if the line real of s is equals to sigma naught is in the ROC, then values of s for real s greater than a will also be in the ROC. So if the question is that, so if it's given to you xt is right handed sided, means let's say ut, so x of s of it is 1 upon s plus 1 and real s greater than minus 1 is its ROC, if you remember the previous lectures. Then if I plot this, then the ROC of this will be x. One more thing, pole is denoted by x and a 0 is denoted by this, and you plot it on this, the axis system. Now so you have ROC of this form. So this property states that if you have this is your ROC. Now consider it that if the line RES equals to A is in the ROC, then all the points which are after A will also be in the ROC. So for the sake of assumption, we assume that our A is equals to 0. So if I am saying that A is in ROC, then all the points which are coming after A will also be in the ROC if xt is a right-handed system. Alright, the next is the property which is for left-handed system, which says that if x of t is left-sided and if the line real s equals to A is in the ROC, then all values of s for which RES less than A will also be in the ROC. So this is, for example, we have x of t is equals to e raised to the power minus t u of minus t. So in this case, we have a Laplace transform x of s is equals to minus infinite to 0 equals to sorry, we forgot to mention this is 0, so it's minus infinite to 0, so it will be equals to minus 1 upon s plus 1 with the ROC real s less than minus 1. Now in contrast to this means is that if I plot this, then it will be in this form. Real s, so it will be, let's say, minus 1 is here, so it's a left hand sequence, so our ROC is this. Now if I say that minus 2 is in ROC for a left handed sequence, then all the points which are on the left hand side of ROC will also be in the ROC. So minus 2 will also be in the ROC. That is what this property says. So if a point says minus 1 is in ROC, then all the points which are on the left hand side of ROC will also be in ROC for a left handed sequence. For a right handed sequence, on the right hand side of that particular pole or the point. The next property is property 6. If xt is two-sided and if the line RES real S equals to A is in the ROC, then the ROC will consist of a strip in the S plane that includes real S equals to A. So what this property says is that if xt is two-sided and if the line real S equals to A is in the ROC, then the ROC will consist of a strip in the S plane that includes real S equals to A. So for this, if we consider an example, xt equals to e raised to the power minus t u of minus t and plus so you can see that this is completely an example when you have two-sided sequence. So if you find the Laplace transform of it, it will be, we can use the previous example from the answer for the answer. So it will be plus 1 and this one will be, for this, the first one, the ROC is less than minus 1, and for this greater than minus 2. So if I have to plot the ROC, or if you, first of all we have to find the common ROC. The common ROC will be between them. So it's real S greater than minus 2. So the ROC is basically basically a strip parallel to j omega axis. So if I have to sketch it, and ROC is this. So what this property states is that if x reaches to, then the ROC will consist of a strip in the S plane that includes the line equals to A. So if we consider that A is somewhere between them, and if the line RES equals to is in the ROC, then the ROC will consist of a strip in the S plane that includes the line this. So if we assuming that we have a somewhere between them, then we can clearly see that the ROC is a strip which is including A. So these are the 6 properties of the properties of region of convergence. In the next video, I'm going to cover the different properties of LTI system and Laplace transform associated with them. Thank you. Please like, share, subscribe my channel for more videos.